Hello everyone. This particular video will constitute as the review for section 2.5, combining trigonometric functions. As you read your textbook on this particular section, you'll find that it gets a lot into the minutia of plotting points and then adding y coordinates together or subtracting y coordinates, and I really don't want you to go through all of that. So the way that these particular questions are set up is for you to intuitively have a general understanding of what's going on with the pieces of the functions to create the graph, and then from that alone you can sort of guess what the answer is. And I'm going to go through several of these to sort of teach you how to do that. In order to do this, though, you must have a good idea of what the basic functions are, like y equals x, x squared, square root of x, absolute value, that sort of thing. Okay, so let's go ahead and get started with number one. So for number one, we see that we have y equals 2 square root of x plus 5 times cosine x. Okay. And so in general, what we know here is that square root of x looks like this. So 2 square root of x would basically look like the same thing, just stretched a little higher. For 5 cosine x, if we looked at it, we know that that would generally look like this, where this would be starting at 5 and fundamental periods in between 0 to 2 pi. Okay. Now, what we want is a combination of the square root function and the cosine function. So if we had to put those together and mix them, it would look something like this. So of course we would start off at 5 here, because the y coordinate for the 2 square root of x would be 0. The y coordinate for this would be 5, so 5 plus 0 is 5. So we would start here, and then we would need to slowly move up this way while still at the same time vibrating back and forth. So we would have something that kind of looks like this. Okay, so I'll go ahead and erase all this stuff here. All right, so in general, like I said, it will continue to come up like this. So if we look at all of our functions here, you'll see that, of course, A doesn't work, because A is just the two graphs that we had in the beginning superimposed on each other. And of course, that's not a function because it doesn't pass a vertical line test. B has a gap in between here for values of x that are greater than or equal to 0, so that couldn't be it. C, although it looks like it would be it, if we look a little closer, we'll see that the y-intercept is at 1, 2, 3, 4, 1, 2, 3, 4, 5, so that actually looks okay. If we look at D, you'll see that we have y-intercept at 1, 2, 3, 4, 5, 6, okay? So D won't work. So A, B, and D won't work, so the answer must be C. All right, let's move on to number 2. For number 2, what we want to do is take 2 cosine x and subtract 3 sine x from it. All right, so coming back here, we'll go ahead and erase these graphs that we did last time. And we will get started on this one as soon as that's done. Okay, so just like how we did before, we want to graph what 2 cosine x looks like and minus 3 sine x, and sort of see how both of those combined together would possibly look. So for 2 cosine x, it'll look like our general cosine function, just stretched a little higher. For -3 sine x, the graph would look like minus sine x, which would look like this within the fundamental period from 0 to 2 pi. And so if we did a combination of those two, first thing that we would see is that our y-intercept would be at the point 0, 2. Okay? Because if we take y equals 0 and then y equals 2 added together, that would be at the point 0, 2. So any graph that does not have a y-intercept above the x-axis, we are going to eliminate that as an answer choice. So if we have A, B, C, and D, if we look at A, it has a y-intercept that's above the x-axis. If we look at B, it is on the x-axis, so that would be out. If we look at C, it's below, so that would be out, and D is above. Okay, so we see that the answer now is in between A and D. How we are going to figure this out is, if you notice, sine and cosine functions are very similar to one another. Matter of fact, the only difference in between them is a phase shift. So for instance, I have a cosine function drawn here. I'm going to draw a sine function next to it for the same length of x values. If I wanted my sine function to look like cosine, all I would have to do is do a phase shift to the left. So we know here, we know that sine of pi over 2 is equal to 1. Okay? So if we take this point and we dragged it back pi over 2 units to the left, we would see that this particular sine function would actually turn into a cosine function. So what that tells us is that the sine function is really the same as the cosine function, just with a phase shift of pi over 2 to the left. So what we want to do here is pick the graph out of A and D, which shows us having some kind of phase shift. Okay? And if we look at A, we'll see that for A, it looks like a perfectly nice round cosine function. Matter of fact, it looks like cosine of 2x exactly, without the -3 sine part in it. So for this reason, we would suspect that A would not be the answer, and thus D would have to be, because we see that it looks like a sine or cosine function with some kind of phase shift. So if we check that, we see that we are indeed correct. All right, let's move on to number 3. So for number 3, this particular problem, we want to do the same thing. Draw a cosine function, draw a cosine 2x, and then sort of guess which one of these would go with that. Now for these problems, we see that we have cosine x, cosine 2x, and the resulting graph all graphed together. So we want to get an idea of what the cosine x, cosine 2x look like, and then after that, we'll start deciphering our answers based upon what's incorrect in each of these. Okay, so again, I'm going to erase what I have here, and then we'll get started. So once again, cosine x just looks like this. Starts up here, goes down, comes back up. Our cosine of 2x, we know, looks just like cosine x, but we have to fit 2 times the amount of the signal within the same amount of x values. So we would go here and then do this again, where this would be at pi. So the first thing that we need to check is to make sure that the choices that we have both cosine x and cosine of 2x looking correctly. So let's check that out. Move this over so we can still compare. So if we look at A, we'll see that A, the blue graph, is representing, sorry, let's go to the black graph first. So the black graph looks like cosine of x, but since it starts below the x-axis, that would be minus cosine of x. So we know we need a positive cosine x, so that would not work. So A would not be our answer. Let's move on to B. Let's see how that looks. So if we move on to B, our black graph starts off being cosine of x, and that looks good because it looks just like the graph that we sketched. If we do cosine of 2x, it should look just like the black graph, but we have twice as much within the same amount of x values. So we look at our blue graph to see that, and you notice here that the blue graph starts below the x-axis. So even though it does look like a cosine of 2x function, it is a minus cosine 2x, which is not what we need. We need a positive cosine 2x. So B would not be the answer. If we move on to C, we look at the black graph again. The black graph represents cosine of x, which looks good. The blue graph here, if we look at it closely, it starts off at the origin, so it looks like a sine function, and actually it turns out to be sine of 2x. And you notice how it has 2 full cycles of sine within the fundamental period from 0 to 2 pi. So C would not be the answer either. So we go on to D and check this one out. And you see that for the black graph, we have cosine x from 0 to 2 pi. And then for the blue graph, we need cosine of 2x. So they both start at the point 0, 1. And we have 2 full cycles within 0 to 2 pi. So the black graph and the blue graph check out. So the resulting graph in red is what it should be. And so we see here that D has to be our answer. Okay, let's move on to number 5. So for number 5, we see that we have function y equals x plus sine of 6x. So I'm going to erase this right quick and then we'll discuss this quickly. So here we have a function that is comprised of a line with a positive slope. So a line with a positive slope, which looks like this, along with a sine function that is vibrating very fast because it has 6 for B, which means it has to fully cycle 6 times within the fundamental period. So we'll have a function that's vibrating very fast like that. So if we look at all of our answer choices here, the best choice that looks like it's mixing a line with a positive slope and a cyclic periodic function together would be C. So I'll go ahead and select it. I'll talk quickly about why A, B, and D would not work. So if you look at A, we have the sine 6x part by all the back and forth vibrations there, but it looks like it's mixed in with a rational function, in particular the rational function 1 divided by x. B looks like we have sine of 6x mixed in with a parabola, or y equals x squared. And D, although it looks like we have sine of 6x mixed in with a line, that line has a negative slope instead of a positive one. So this is why C would be our best choice for an answer. All right, moving on to 6. So again, we have our cosine of x plus sine of 3x, and we want to see which one of these this would possibly look like. And so I'm going to erase, and we'll talk about this for a second. So here we know that our cosine function, again, is just going to look as follows. Okay, and we have our sine 3x, which we know for one full period, since our b here is 3, we know that for one period that would be 2 pi divided by 3. So we would actually have 3 of these for every one of those. So I'll go ahead and redraw that to make it look a little bit more like how it should. So we have here from 3 pi. So we divide this up into 3's. So this would do 1, 2, 3. So that's how it should look. So we're going to mix a cosine signal, which has what we call a low frequency, with the sine signal, which has a high one. So if we look at all these answers, there are some answer choices that we can rule out. So A will be ruled out because we're mixing a trig signal with a line. B would be ruled out because we're mixing a trig signal with a parabola. C will be ruled out because, again, we're mixing a trig signal with a line. D could possibly work, and E could possibly work because they just look like another trig function mixed with another. And F would not work because it looks like we have a trig function mixed in with a rational function. So out of all the answer choices that we have, the only ones that would possibly make sense would be either D or E. And so now we need to figure out which one of the two would actually work. Well, you notice that for D, the y-intercept for D is above the x-axis, whereas for E, it is on the x-axis. Now, if we plugged in 0 in for cosine x and sine x, we would have cosine of 0 plus sine of 3 times 0. And we know that cosine of 0 is just 1 and sine of 0 is 0. So our y-intercept would have to be above the x-axis. And so because of this, that rules out E. And so therefore, D would actually be our best choice for an answer here. All right, so for the last problem, number 7. So we see that we have a business owner who has 2 businesses. One of them is growing exponentially at a rate of 1%, and the other business is cyclical. And the higher profits in the summer rather than in the winter. And so he's characterized the profits from the business as being a summation of an exponential function, the 1200 times 1.01 raised to the x, plus a trigonometric function, 600 times sine of pi over 6 of pi over 4, x minus 4, plus 2400. And that gives the total profits as a function of months, with x equals 1 corresponding to January of 2005. And so what we're first charged with is trying to figure out what the graph will look like for the first 60 months. So how we can actually go into looking at this is we can look at the function in all of its pieces. So we see we have a piece that is exponential looking. So that is the 1200 1.01 raised to the x, this particular function will look something like that. We have the 600 sine of pi over 6 of x minus 4, and of course this is going to look like a sine function. And one thing that we do want to note is here, since we see that we have pi over 6 here, that's our b. So our period for this, if we calculate it, our period for this would be 12. Okay, so our period being 12, that is a very, very large period. So what that means here is that this particular sine function is vibrating very slowly. Okay, so now we want to do the last part, which is the 2400, and of course that is our vertical shift. So we need a function who's going to be going up in an exponential fashion, also going to be vibrating sort of slow, and be bumped up at least 2400 units. So if I were guessing here, I would think that my function would have to look something like this. So if this is 8,000 and this is 4,000, it would have to be possibly somewhere down here and kind of doing something like this. That's what I'm guessing. Now, it's also possible, depending upon parts of our function here, that it could raise above 4,000 and do like this. We have to check out what's going on and see. And the way we're going to find that out is by trying to figure out what our y-intercept would possibly be. And so how we'll figure that out is we'll just plug in 0 for each of these pieces here to see what it ends up being. So for starters, we know that the 1200 times 1.01 raised to the 0, that's just 1200, because anything raised to the 0 is 1. We have 600 sine of pi over 6, and then if we plug in 0 for x, that would just be -4 there, which would be a 600 sine of negative pi 4 pi divided by 6, which this is the same as 600 sine of negative 2 pi over 3. Okay. Now, we know that sine is what's called an odd function. We talked about that in class. So this would be a minus 600 sine of 2 pi over 3. Okay. Now, we know we can actually evaluate sine of 2 pi over 3, and you'll find out that this portion here is going to be square root of 3 over 2. But in general, we know that this thing at most, sine at most, is either going to be 1 or at the very least going to be -1. So even if we would have been at, let's say, sine of 3 pi over 2, and this would have been a -1 here instead of square root of 3 over 2, adding 600 to 2400 would only get it to, let's say, 3,000 at the most. And adding another, let's say, 1,200 to that would barely get it over 4,000. So we know that this is less than 1. So my point in all of this is that the graph that we should actually go with here should be the one down here at the bottom. So this one. Because the y-intercept isn't going to get over 4,000. Because we see we got 1,200 here, 2,400 there. And so this amount is going to be less than 1. So even if it's positive or negative, it's still not going to get you up to the 4,000 that you need. So at the end of the day, if we go back and look here, we should pick the function that rises, vibrates slowly, and that is below y equals 4,000. Yeah. So A and C would not be it. So we have to choose in between B and D. Now, from what we see here, we know that it has to be at least 3,600 because of the 1,200 here plus the 2,400 for the vertical shift. So 4,000 is about here. So it would not be way down here. Sorry, let's look at B and D. It wouldn't be way down here. It would have to be somewhere close to the middle. So D would probably end up being the best answer there. Okay. All right. And so it says the next part of this, what does a graph look like if the domain is 600 months? Okay. And so if the domain is 600 months, then the graph is going to look probably more like an exponential more than anything else. Okay. Because here the exponential function is growing much faster than the other two, and so the exponential part will take over it. And that concludes the review for section 2.5.